Okay, so we're going to find the surface area of this curve. So we're rotating around the x-axis. So right away, I just want to be clear we're using this formula, right? 2 pi y ds. All right, so I'm going to say that the surface area equals integral 2 pi y ds. And we can make the decision on whether we want to integrate with respect to x or y. Well, in this case, they're giving us the equation of the curve is a function of x, so it makes the most sense that I would want to integrate with respect to x, right? Everything's already in terms of x for me. Okay. So then what I want to do is integrate 2 pi, and y I'm going to consider a function of x, so I'm going to replace it with f of x times the integral 1 plus f prime of x squared dx. So I'm integrating with respect to x. I would want to integrate along the x-axis then. That means that my limits of integration should just be x coordinates. So I can do this two ways. We can go from -1 to 1, or we can just realize that this is symmetric, right, about the y-axis. So I could technically just go from 0 to 1, and I'll multiply it by 2. So that's just going to find me this half of the surface area, right? And then I'll just multiply that half of the surface area by 2, and I will be done. Okay, so let's work on a couple of things first. Let's find this, f prime, then we'll square it. So f prime of x, actually before I do that, let's just take f of x, which is the square root of 4 minus x squared, and let's rewrite it as 4 minus x squared to the 1/2. And then we'll do f prime. F prime of x, we're going to use the chain rule, 4 minus x squared to the -1/2 times the derivative of the inside function is going to be -2x, right? All right, let's simplify this. Then this 2 will cancel out with this 2 in the denominator. I'm going to drop the 4 minus x squared to the denominator and put it back under a square root. And I still have a -x in my numerator, right? So that's f prime of x. All right, well, I need that squared, so I'm just going to square both sides, which is going to give me x squared in my numerator over 4 minus x squared in my denominator, right? All right, well, let's go back up to my formula and look at what's under the square root. I'm also going to need to add 1 to that. So let's just do that right now, because we're going to want to combine everything and simplify as much as possible. So I'm going to go, okay, so 1 plus that. So I'm going to have 1 plus x squared over 4 minus x squared. Let's combine those to make one fraction. So I'm going to change the 1 to be just 4 minus x squared over 4 minus x squared. And then I'll have plus x squared, plus x squared over 4 minus x squared. All right, and then adding those, you'll have that x squared in the numerator that cancels out. And you'll have 4 over 4 minus x squared in the denominator. All right, so let's see what we have now. If I write this out, I have 2 times the integral from 0 to 1 of f of x is just root 4 minus x squared times. Now, notice that that's everything that's under the radical, right? So this is really the square root of 4 over 4 minus x squared. Well, you can take the square root of the numerator. That's just going to be 2. And then I'll have times 1 over the square root of 4 minus x squared, right? All right, so that's what I'm going to be multiplying by. I'm going to be multiplying by 2 over root 4 minus x squared. And this is going to be dx. Okay, well, things are sort of wrapping themselves up in a nice little package, because what's going to happen to that square root? Well, we have 1 in the numerator, we got 1 in the denominator, that's gone, right? And now we're just integrating 2 times the square root from 0 to 1 of 2 dx.
Mr. Toller, what happened to the pi in the...
Oh, yeah, thank you so much. Oh, boy, I dropped that. There's this 2 pi, actually, right, that I just left out. We can pull that out right here. Sorry. Thank you. And so then that's just going to be a 4 pi out front. Right. All right. Now let's finish this up. Antiderivative of 2 is just going to be 2x from 0 to 1. 4 pi times 2. 8 pi is our final answer.
I don't feel bad correcting, but I think there's an extra 2 in there now.
Okay. So this one we're rotating around the y-axis. I think this one I might do 2 versions of. Oh no, maybe we'll do that in example 3. We could do it here too, though. All right. So take a moment and write this down. So we're taking the parabola y equals x squared, which is that guy there, but we're just looking between the point 1, 1 and 2, 4, so just here. We're going to rotate that around the y-axis to make what kind of looks like a frustum, although not a frustum, because a frustum of a cone would have a flat slant, and this has a curved slant. We want to find that surface area. All right, let's do it. So first off, we're rotating around the y-axis. So we want to use this version of the formula, 2 pi x ds, where ds, remember, could be either of these depending on what we choose to integrate with respect to. All right, so I'm just going to write down the general formula that we'll be using. So y equals the integral 2 pi x ds. Now, just looking at the way our function is set up, is it going to make more sense to integrate with respect to x or with respect to y, do you guys think? What would you like to do? Just give me an x or a y. Don't ice me here. Tommy, why do you think y?
Because it's across the y-axis.
We are going across the y-axis, right? I agree. And normally, because I think you might be thinking in terms of volume. You're like, okay, well, if I'm doing volume, maybe I want to do cross sections with respect to y, or I want to cut them horizontally. So then I would need to integrate with respect to y. But that's not the case here. In either version, you can evaluate it with respect to x or y. It doesn't matter. So it doesn't really matter which axis you're rotating across. What matters is how are you given your function. If it's given as a function of x, go ahead and integrate with respect to x. If it's given as a function of y, then it's fine. Go ahead and integrate with respect to y, whichever is easiest. This is given as a function of x already, right? It's y equals x squared. So I would want to integrate with respect to x, which is fine. So the way I do that is I'm just going to leave this as x, right? So it's going to be 2 pi x. And then the ds, I'm going to use this version of ds, the one where I'm integrating with respect to x. So root 1 plus basically f prime of x squared dx. And I'm going to do this both ways just to show you that it would come out the same. All right. And here, since we're integrating with respect to x, we're going to integrate across the x-axis. So we're going to use the x-coordinates, so from 1 to 2. All right, well, let's try it. I can pull out the 2 pi. Oh, what? Before we do that, let's get what's going on underneath there. So let's find f prime first. So f prime is going to be easy enough, 2x, right? Square that. That's 4x squared. And then I'll add 1 to it. I can bring the 2 pi out front. I'll have x root 1 plus 4x squared dx. There we go. Now we just need to evaluate. What technique would you guys use to evaluate that integral? Don't be shy. How would you evaluate this integral? What technique? Trig sub, partial fractions decomposition, U sub. Well, notice, look at the power of x under a radical. It's x squared. If we did a U sub, right, you would end up with du with an x, and we do have that outside our integral. We should just be able to U sub this. So let's do that. Let u equal 1 plus 4x squared. Then du is 8x dx. We don't have 8x, but we do have x dx. So I'll just move over to the 8. So 1/8 du is x dx. All right, so if I apply that u sub, I still have the 2 pi. I'm going to bring out the 1/8 integral. This just becomes square root of u du. And then I don't really want to go back to terms of x, and this is a definite integral. So let's go. All right, help me on the chat here. When x is 1, what should u be? What's my new lower limit of integration going to be? When x is 1, what is u equal to? Is my chat broken? Am I on mute? Or are you guys just icing me out? There we go. Thank you, E-Man. I agree. 5. And that's just plugging 1 in for x. If I take 1 and I plug it in for x here, I get 1 plus 4, so u equals 5. What's my new upper limit of integration? So x is 2. What's u? $17. So 4 times 4 is 16. Good. And so what we have here is just an equivalent definite integral, but now we don't need to go back to terms of x at all. We can just evaluate this in terms of u and we'll be done after this. So this is a much more reasonable integral to deal with. All right, 2 pi times 1/8 is pi over 4. And then just remember this is actually u to the 1/2. So we'll anti-differentiate. So we'll get 2/3 u to the 3/2. And that's from 5 to 17. And then we'll plug this in. Oh, whoops, not pi over 4 equals, pi over 4 times. I apologize. This doesn't look to come out very nice. It kind of seems like it's going to be nasty, but that's okay. So we'll get pi over 4 times 2/3 17 to the 3/2 minus 2/3 5 to the 3/2, which I think is going to come out to be some weird irrational number, but let me check. Let me see if they just give us a decimal approximation of it. No. I mean, we'll just leave it as is. We're going to redo this one, but I'm going to show you that we could have integrated with respect to y and gotten the exact same thing. So we'll keep in mind what we have here. I'm going to erase it. And now let's do it if we wanted to integrate with respect to y. We would still need to use the same formula since we're rotating around the x-axis. So the area is still the integral of 2 pi x ds. But if I wanted to integrate with respect to y, I would go integral of 2 pi. And I would rewrite x as a function of y. And then I would do integral of 1 plus that f prime of y squared dy. Okay? And since I'm integrating with respect to y, I would then change my limits of integration to be the y coordinates. So it would go from 1 to 4. All right, well, this means we need x as a function of y. So we would actually have to solve this because it's written in the other way. That's not too hard. We just have to take the square root. X equals the square root of y, right? And it would be the positive square root, which would give me the right half of this parabola, because that's where all the x values are positive, right? So that's good. All right, so let's go down here again, and let's go, okay, well, I need f prime of y. Well, square root of y is just y to the 1/2. Oh, no. So f prime of y is just 1/2 y to the negative 1/2, right? And then I want to square that. I'm going to square both sides. And that would be 1/4 y, and the power of a power, we should multiply those exponents, so that's 1/4 y to the -1, right? Or 1/4y. And then I want to add 1, because I'm going to get everything under the radical kind of simplified as much as I can. So that's going to be 1 plus 1/4y, or 4y/4y, just changing that 1 to have a common denominator, or 4y plus 1/4y. All right, then let's just pay close attention. When we take, let's see, the square root of that, I guess the only thing that can come out of that is I can take the square root of that 4, so I can basically bring out a 1/2 here, and I would have 4y plus 1/y, or 1/2, just divide y into both of those, 4 plus 1/y. Okay, so let's look up here. All right, this goes back to equaling integral from 1 to 4 of f of y, which we decided, oh, I'm sorry, I almost did it again, Alex. 2 pi times f of y, which is root y, times 1/2 times the square root of 4 plus 1/y. Actually, I'm going to do something else. All right, sorry, I should have just done this at the beginning. Just pay attention to that. I can factor out a 4 here and write 1 plus 1/4y here, right? So just think of if I distributed that 4 back in, I would end up with this. And that means I can pull out the square root of 4, which is 2, which is going to cancel that out. All right, so now let me rewrite that. Apologies. Integral from 1 to 4 of 2 pi root y times root 1 plus 1/4y. Oh, dy. Where is my good notation? There we go. So since that y is also under a square root, I can actually distribute it inside this, this other radical. When I do that, I'm going to get integral 1 to 4 of 2 pi. I'm going to have root y plus 1/4, right? dy. And now we're ready to try and evaluate this integral. Well, what's under the radical? There's only the first power of y. So we should be able to just make a u sub. So I'm going to let u equal y plus 1/4. And that means du just equals dy. All right, so that's great. I'm just going to pull out the 2 pi integral root u du. Let's update my limits of integration. So let's see, help me out again. When y is 1, what would u be?
Five fourths.
Yep. It'd just be 1 plus a fourth, which is 5/4. And when y is 4, what's u?
17 fourths.
17/4. Let's go ahead and evaluate. We'll get 2 pi from 2/3 u to the 3/2 from 5/4 to 17/4. And then plugging in, we get 2 pi times 2/3 17/4 to the 3/2 minus 2/3 5/4 to the 3/2. And this is actually exactly what we got in the first one. Now you might go, wait, I remember the 17 and the 5. I don't remember the over 4. But we also had a different factor out front. So if you were to pop both answers into your calculator, you would end up with the exact same decimal. And so the whole point of this was to show that with surface area, it doesn't matter. You can integrate with respect to either variable, and you generally just want to choose which variable to integrate with respect to based on the way they've formatted your function in the first place. The only time you need to change formulas depends on if you rotate around the x or y axis, and that's the difference between 2 pi x dx, and that's if we're rotating around y, and 2 pi y dx, and that's if we're rotating around x. All right? So we're going to do one more example, but I'm just going to have you set up the integral. You don't have to evaluate it, okay? All right, I'm about to go over this. Let's start with x. So if we're rotating around the x-axis, we want to use this formula. So integral 2 pi y ds. Now, I'm going to do this one in terms of x. And all that means is we're going to want to rewrite y as a function of x. And we're going to want to use the version of ds that has the differential dx at the end. And then also that our limits of integration should be x coordinates. So this is probably the easier version to set up because everything's already put in terms of x for us, right? So my limits of integration, they tell us, are 0 and 1, and that just comes from the x restriction they give us here. And then I would do 2 pi, and instead of y, I want to write what y is as a function of x, so that's e to the x. So 2 pi e to the x. And then I'll do radical 1 plus, now I need f prime. This one's not bad because the derivative of e to the x is just e to the x. And then I'll square that, dx. And that's it. There's my integral. That'll give me the surface area of that curve rotated around the x-axis between x equals 0 and x equals 1. Are there any questions on that one?
Can you write e to the x squared as e to the 2x?
Yes, you can, absolutely. All right. Now let's do the one in terms of y. So you have to do a little bit of prerequisite work here, a little bit of algebra stuff. But I'm going to give you another 3 or 4 minutes, try that one, and then I'll come back and explain it. So even though I want you to integrate in terms of y, we're still using the same general formula because the formula is only dependent on which axis we're rotating about. We're still rotating about the x-axis. So I'm still using the formula integral 2 pi y ds. The only difference is I'm gonna be integrating with respect to y. So I'm gonna leave this as just a y. I'm not gonna rewrite it as a function of x. This is now just the variable y, and the ds is going to be root 1 plus f prime of y squared dy, right? And I'm going to need y coordinates for my limits of integration. All right, so I said you had to do a little prerequisite work then, and that's I need to solve that equation to be a function of y. So how do I isolate x in that equation?
You take the natural log of both sides.
That's it. So x equals natural log y, right? So there we go. Now we have x as a function of y. I can say that, let's go down here. F prime of y, what's the derivative of natural log?
1 over x.
In this case, 1 over y. And then we'll just square both sides. And I get 1 over y squared, right? All right, so this just becomes the integral of 2 pi y, 1 plus 1 over y squared dy. And now I just need my limits of integration, which means I need to know what y is when x has those values. So I need full coordinates, right? And so I know that coordinate's x equals 0, and then this coordinate's x equals 1. And all I'll do is plug those in for x to get my y outputs. So if I plug in 0 for x, I get e to the 0, which is 1. And if I plug in 1 for x, I get e to the 1, which is e. And so my limits of integration are from 1 to e, right? All right, and you can verify that. There's my answer. These will give you the exact same value. So if you want to convince yourself, just integrate it in your calculator, right? So integrate that one from 0 to 1, integrate this one, and it doesn't matter. You can still just use x in your calculator. Y is just the name of a variable. It doesn't. I can call that variable a, b, c, d, whatever, and I'm still going to get the same value for that definite integral. But in your calculator, you would see you get the exact same value in either case.